example of a company making use of object detection is Remo.ai. It just recently joined the agri-tech company AppHarvest, and AI is at the core of everything they do. Here we have real-time detection, gentle touch, and intelligent motion. Under real-time detection, the systems can see fruits and understand whether they are ripe and ready to pick, even in highly cluttered and complicated growing environments. And then with a gentle touch, the patent-pending grippers can reach deep into the tangled vines and pluck a single ripe fruit without leaving a mark. Finally, here with an intelligent motion, they could move around, or this robot moves around using its sensors, which see the world in full 3D and hence can plan the right path to the target. Here we have this demo of this real-time detection system. We see that this robot equipped with a camera is able to detect the ripe and the unripe fruits, and this obviously will permit this robot know whether to pick a given fruit or not. So coming back to our project, we're gonna build a model which is able to detect fruits. But before looking at that, we would have to recall that we're working on a machine learning project, and every machine learning project has some sort of development life cycle where we go from the task right up to the corrective measures. Here we have the task, the data, that's data collection, preparation, treatment, the modeling, error sanctioning, training optimization, performance measurement, validating and testing, and finally corrective measures. So we're gonna go through all the steps. Now firstly, we have to define the task. We are trying to do object detection, that is when given an image like this, because actually this is what the robot sees. This robot equipped with a camera, which could be located around this, sees this image right here, or sees this plants, and once it gets this, it has to be able to locate accurately the positions of these fruits. You see here for the green and then for the red. So in this case, this robot is basically doing detection of the ripe fruits and the unripe fruits. But then how are these fruits located in the image which this robot sees? Firstly, we have to understand that each position in this image is with respect to an origin, and this origin is found at the top left corner. So here's our origin right here, and this image could have a width and then a height. Let's take an example of an image with width 1024 pixels and a height of 768 pixels. So as we said, the location of each of these fruits is with respect to the origin. Hence, if we want to locate this particular fruit, let's take this example right here. We would have this. We would have in the width, that's going from this origin, this width axis, we have 312, and then going in this height axis, we have 576. So that's how we locate this edge right here on this bounding box surrounding this fruit. Then this other edge, we have on the width axis 318, the height axis 585. Now this is generally known as the x min y min, and then this the x max y max. Zoom on that, and we have this. So every object here is located via this 2 points. That's the top left corner of the bounding box and the bottom right corner of that bounding box. Here the x min y min, and here x max y max. And it is based on that location that this robot actually picks a given fruit. But it should be noted that given we are having two different classes, that is one with a ripe fruit and the other with unripe fruits. If this robot detects a fruit, it has to decide whether that fruit is ripe or unripe. And so here we not only have the detection task, but we also have a classification task. That is, we have to say for every object whether it belongs to a given class or not, and also precisely locate that object in the whole image with respect to the origin. So now we've understood perfectly our task, we could now go on to the data preparation. Talking about data preparation, the exact formatting of our data will be the same as that of the Pascal VOC format, where we can have this image right here and then this annotations XML file. In here we have the folder, the file name, we also have the source, we have the owner, we have the size, as you can see 353 by 500. So we go from the origin 353 and then by 500. Depth 3, since the image has 3 different channels. Then we go for each of those objects. We basically define the position of each object and also the class this object belongs to. As you can see right here, we have just 2 objects defined because in this image we have just 2 objects. The first is a dog. We're given this pose, see whether it's truncated or not. Difficulty level, that's difficulty to detect it in this image. And then we have the bounding box, which defines the exact position of the dog. Right here we have the x min, y min defined and the x max, y max defined. So if we go to the x location 48, y min 240, we should get to the x min, y min, and then at this location 195, 371, we should get to the x max, y max. We could repeat the same process for the person, the pose defined, truncated nature, difficulty, and then the bounding box. What's important for us to note here is the class, that's the person, and then your bounding box. For the fruits, we may have a ripe fruit, the bounding box, and then we could have unripe fruit and then the bounding box. If we have many fruits, say 100 fruits in one image, then we shall have 100 of these objects right here. Now let's draw some bounding box about this, around this dog. Let's come to select. There we go. We draw this bounding box, supposing it's this. And then for the person, it should be around this. And now we shall compare it with what we get in the XML file. For the dog, we have 48 to 40. So let's be at this position. See, we have about, you could look at the down here. So here we have about 44 to 40. So that's kind of like almost the same as what we have in the XML file. And then the X max, Y max, we have 221, 399. Here we have 195, 371. So we should have been around 195. It's around this. 371. Let's go up 8, and then we are on this. So we should have been around this for this X max, Y max. For the person, we have 812. So we're on this 8. We should have gone left and then slightly up, so it's around this. And then for the X max, Y max, 352, 498. So we are around this. And that's it. That's how this image has its classification and its object detections stored in this XML file right here. After looking at the Pascal VOC data format, it's clear that for every data point we have an image and an XML file containing the bounding boxes of the objects in this image and the classes of these objects. By default, the Pascal VOC dataset comes with a total of about 20 classes, but in this example of the fruit picking robot, we are interested in just 2 classes. That is a fruit which is ripe and another which is unripe. Now to simplify this problem even further, we could just have one class, and that is the fruit class. So instead of detecting objects like a person, a car, a train, a bus, here we're detecting fruits. A great tool which permits us manage or create this custom image data sets for our detection is the Remo.ai. So this helps us manage from here. How do you manage your image data set? You have thousands of images and 10 times as many annotations: organize, annotate, and visualize. So this is Remo.ai for you. Yeah, you could visualize your data set, annotate, as you could see right here. We could also have the local installation, which we shall do shortly. The pricing is free for community, and then paid for teams. So we have that and this. Okay, let's go ahead and get Remo. That's free. We have this. This is a demo of how it works. Now let's look at this quick installation. Here we have pip install Remo, this command, and then we can launch it from here. So we just simply follow this tutorial, which the make readily available for us. So basically with this, after following this tutorial and then launching from here, we have the Remo app which is running, as we could see right here. And then here we could now actually see our Remo app. Now we'll create a new data set, that is fruits. Create that. Once that's created, we get into this fruits. You see here we could simply add data. There we go. We add this data. We're gonna add images only. We would use local data. So yeah, we're gonna click on browse folders. There we go. We pick out this folder right here. So we select this folder, and then we'll load this data into Remo.ai. So that's it. Upload. And then here are images right here. You see we have only 25 images or 25 items, but if you were in a production environment, then this number of items should increase to even tens of thousands of images in order to increase your model's performance. So that's it. We have our images. We can now go ahead to annotate. For now, we type in the name of the annotation set. Just say fruits annotation or fruits bounding boxes. Select the task. We're in object detection, so we have that object detection. We create. Now we go under annotations, and then we annotate. So yeah, we have our 25 different images, and then we could get started with this annotation. Now you may be feeling like this task of annotation is the least important, as maybe you may want to just dive into the code and start typing in some stuff to make your model work. But it's important to know that this is the most important step in this object detection or fruit detection project, as even if you have some state-of-the-art model and your data is poorly annotated, you'll still have very poor results. So it's important to take this step very seriously. Right here, we just simply start with annotation. So that's it. We now come right here. We have draw a box. We have draw a box, shortcut, zoom in, and then grab. Now, before drawing the bounding boxes, let's create two classes. We have ripe. So there we go. We have ripe. We add that. And then we have unripe. Unripe, we add that. So that's fine. Now we have that grab. Take this to this edge. We pull that down. It's very easy to use. So you just have that and select ripe. Save. Could drag this to the edge. Click on that again. Pick this out. So that's fine. Ripe. Save. Click on grab again. This one unripe. So that's it. We have this unripe. Save. Click on that again. There we go. Here we have ripe. We save. Click on that again. So let's take this as edge. There we go. We have write, save, and then finally we have this one here. We have this here. Click on that. Write, save. So you find that if an error is made while doing this annotation, that is, if for example, instead of sending this to or choosing this class as ripe, you will pick it as unripe, then your model will perform poorly. So it's very important to make sure the annotation is done properly, and that's why this Remo.ai tool comes to make this task very easy. So that's fine. We could click on done. So that's fine. You see, we go to the next image. Now if you get back to this, you have that. Now we could go to the next image. Could zoom this a little. Now let's delete that. Come back to this. Or use the hand. Zoom this. Zoom that. Okay, so that's fine. Now we don't have fruits up here, so let's just focus on this part. Zoom this again. So that's fine. As you could see, these images have been taken on the internet, but in case you're working on a production project, then you have to collect these images on your own, and the images you collect have to be reflective of what the robot is going to be seeing when it's going to be left on its own to do the fruit detection. So it's very important to gather data which is of the same distribution as the type of data which the robot will be seeing when left alone. So that's fine. We get back to our graph. So it's a very easy tool to use. So we just have that. Grab this, pick that, ripe, save, click on this again. It's fine. Pick that, it's ripe, you save that, grab on that. That's fine. And also note that you may not necessarily need to write the code and then still do this annotation. So the task of annotation can be given to a whole different team, and that's what companies like Tesla do. So it's important to allow this job to be done by the best possible labelers you could have around. So that's it. We'll label that. This is unripe. There we go. Fine. Ripe. Save that. It's okay. Ripe. So this is gonna be our last example. For the rest, we're just gonna load that and then continue. So yes, ripe. Save it. Yeah, ripe. Save that. This one unripe. So the robot, when it gets to this, it doesn't actually pick it because it's unripe. So if you select your ripe, it means when the robot will say fruits of with this kind of color, it's gonna have the tendency of picking it up. Here we have unripe. Save that. Pick this right here. Unripe. Save that. Here we have ripe. Save it. Here we have ripe. Save it. Now the shortcut you could use is by pressing on B. As you could see here, the shortcut B. It's not capital when I use it. It's not with caps lock. So you just press B and then you have that. So after picking this up, I have ripe, save. I press on B and that's fine. So you don't need to come and always click on this. So here I have the fruit and that's it. So here's ripe. So that's it. When you hover on this, you see you have here unripe, ripe and stuff. So that's it. And even if you have hundreds of thousands of images, you have to do this for each and every one of those images. So that's why this step is considered as the most important in this project. We've now annotated all 25 images. There we go. Your annotations. And so we're now ready to move forward to the next step, which is that of exporting these annotations. So right here we click on export annotation. We select the Remo JSON. There we go. for the advanced options. Everything is okay, and then we export. So yeah, we have fruits bounding box. Let's just have this fruits bounding boxes. That's fine. Now when we open up this fruits b box file, what we get is this. As you could see right here, we have the different bounding boxes. We have the bounding box max, the x max, x mean, y max, y mean, the class, here's ripe, here's unripe, 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 and so on and so forth. So for all the 25 different images, there we go. This is what we get. And what we're left now to do is to convert this JSON file into the Pascal VOC Dataset format, which is an XML file. Given that we want to use the Pascal VOC data format instead of the JSON format given right here, we are going to use this data to XML method, which will help us in generating the different XML files for each and every image from this JSON file right here. So we'll generate this and put it in this annotation folder. Let's run this. There we go. And here's the annotations folder. So we have all the different images. You could open this up and see that this is exactly the same Pascal VOC dataset format we had seen previously. So this is an example of a generated XML file for the image 16.png. Now that this is done, we have the annotations, and then we have this images right here. In order to obtain better performance, we went ahead to annotate close to 900 other images, as you could see right here. Since we got these images from the internet, there were a number of duplicates, so we're left with about 600 images. And there we go, we have this 600 images. We have also the annotations, which we've converted from the JSON format to the XML format. And then we have this image sets folder, which contains the main folder right here. And in this main, we have these two files, the ripe.txt and then the unripe.txt. And this ripe.txt will start all the image names. So as you can see, we have 612 images right here. So we'll just simply start all those image names, and then this unripe.txt we've done the same. So we have also 612 images right here. So there we go. We don't need this text folder, so we could get rid of that. Link to this notebook is given in the description below. For this week's giveaway, you would have to recreate a custom data set made of objects or an object of your choice. And then, for example, select the scores. Under this, you apply for scholarship and send out some screenshots of your newly created data sets. So that's it. See you on the next section, where we are going to train a YOLO version 3 model on this custom data set.